Hello everyone, welcome to a session on how to do bearings problems. And our first example is taken from the textbook. Example 25, page 159. Let's read it. The plane leaves an airport and flies 600 kilometres on a bearing of 145 degrees. How far south of the airport is the plane to the nearest kilometre? And the textbook has this diagram which shows us all the important elements. Our airport, the compass, we have our 600 kilometres for the plane, that's where the plane now is. We have a bearing of 145 degrees and X kilometres, how far south? That's the distance we want to find. Please remember, bearings are measured from north only, nowhere else. So we need to know a bearing of something, you start from north and go clockwise. Using a diagram is really essential for these types of problems. How far south means following this line here to find that distance. Now why 35 degrees? That one there. That's because of two things. The one is that if we carry on our 145 degrees further to south, that missing angle is 35 degrees. And we need that in our triangle to use trig to find that length there. We have a triangle from the plane direction and route, the hypotenuse. We have this side here, which is the one we need to find, and we have an unknown side as well coming from the plane straight across to south, forming 90 degrees. So there's our right angle triangle. Now we can use trig. Question is, what ratio should we use? Since we have this angle here and we need to find that side there, and we have a hypotenuse, so it's a ratio with hypotenuse in it. Now compared to this angle here, this side is the adjacent side. So we have an hypotenuse and an adjacent. And there's only one trig ratio that has both of those. And that's cosine, or cos. So when we now set out the answer, cos of 35 is the adjacent, which is x, over the hypotenuse, which is 600. And then to simplify, we multiply both sides by 600 and we get this. 600 cos of 35 equals what we're trying to find. And when you put that on a calculator, 600 cos of 35, we get 491.491. And because it wants the nearest kilometre, we round it down to 491 kilometres. So there's our answer. Next one. What about if you wanted to find a bearing back the other way, from the plane to the airport? And some questions ask this. We know this is 145, from there to there, but what about from here back to here? So we need a new reference point to get in the new bearing. So I put a compass where the plane is now. And we want to find this bearing. Now that's almost all the way back to north. How far short of north is it? Well, let's have a look. We have a north-south line and another north-south line. These lines are parallel. And we have a transversal with an angle. So we know what that angle is because that's alternate. And alternate angles are equal. So this bearing from there to there is 35 degrees short of 360. The other way we can work it out, 360 minus 35 is 325. That's our bearing. The other way to work it out, you can add 180 to 45 degrees, gives you the same answer. That's our original bearing going that way. If we go back the other way, we just add 180 to it, and we get 325. This way is not the best to use always because it can be confusing with some questions. This way is a better way to look at it. Another way to look at it is to see that this angle is 55. 35 plus 55 is 90. So we could go from here, 90, 90, 90, 55 equals 325. Last example. From camp, Andy walks due north for 8 kilometres, then 6 kilometres due west to a lake. How far is Andy from the camp? What is the bearing of the camp from the lake to the nearest minute? Now, without a diagram, can be tricky. Here's our diagram. We have Andy starting at camp, walks due north 8 kilometres, due west 6 kilometres. How far is Andy from the camp? That's how far. Now, fortunately, we can use Pythagoras because we have two sides and we need to find the hypotenuse. So using Pythagoras, x squared equals 6 squared plus 8 squared. X squared equals 100. X is the square root of 100. So we have a distance from the camp of 10 kilometres. That's easy. Then we've got to find this angle here because it's asking for the bearing of the camp from the lake. This direction. And we need to know what that angle is to do it. Now here it's got tan. So why tan? Because we've got 8 kilometres there and 6 kilometres there. So we can use opposite over adjacent. And when we do that, let's get our calculator. With angles, you always have to do the inverse. So shift tan, and we have 8 over 6. Equals, oh, made a mistake, 8 over 6, sorry, let's go back. Let's try that again. Shift, tan, 8 over 6 equals, here we are, that's better, 53.13 and so on, that's what we've got there. And to get the minutes, we press this button, 53 degrees, 7 minutes, 48.37 seconds. That's that angle there. Now to get the bearing, we've got to go from north though. So 90 plus that. The 90 degrees from there to there, plus the angle we just found. So I'll just add 90 to that. 143. And to find the minutes, 143 degrees, 7 minutes, 48 seconds, and because that is over 30, it rounds up to 143 degrees and 8 minutes. Just one more thing. With this, because we know all three sides, 8, 6 and 10, we could use any trig ratio. So I'll just use one more. We'll do cos. Shift and cos. Now cos is adjacent over hypotenuse. Now here's our angle, here's our adjacent, so we need 6 over 8. That should give us the same answer. 6 over hypotenuse, that's 10. That should be 10. Adjacent over hypotenuse. There we are, that's better. Equals. Here we go, same answer. 53.13. So you could use cos or you could use sine. To find the degrees and minutes, 53 degrees, 7 minutes 48, so it's the same. So you could use any trigonometry ratio. Thank you.